Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Jason Birch and Tim Taylor of the City of Nanaimo. Tim has been actively using FME since 2000 and has more than 15 years of experience in the geomatics industry. Jason has been working with GIS since 1992 and is active in the Open Source Geospatial Foundation, sitting on the MapGuide Open Source and FDO project steering committees. Their work has led to Time magazine dubbing the City of Nanaimo as the capital of Google Earth.
So let me ask you a question to start. How many of you feel that you have a hard time describing what you do to people that you meet on the street or your family? Yeah, I feel the same way. I started out talking about myself as a web mapper or a data GIS guy, and that always required extra explanation, and you see the eyes glazing over. They just wouldn't get it. And then when Google Earth and Google Maps came out, I'd just point to those and I'd say, hey, that's what I do. But that wasn't really satisfactory either, because I didn't really get into the details. So lately I've been thinking more about myself as a transformer. Now, I'm not a creator. Tim falls into that role, but I'm not a creator. I'm more like a topology builder. I connect the nodes in my organization and put things together. But you know, when I go home and I tell my kids that I'm a transformer, they get this weird look on their face and they said, are you an Autobot or a Decepticon? So I had to kind of give that up. But I still secretly think of myself as a transformer, and I am an Autobot.
I just tell my kids I'm a surveyor.
So what we're here to talk about today is how we bridge the gaps. And you know, I think that slide gives a pretty clear example, a clear way of conveying the emotion that we feel when we look at all the various data silos in different departments and try and figure out how we're going to connect them without falling to our death in the rapids and suffering some perilous consequences. When I started with my last job, I was working for the provincial government, and everything was either at that time was in ArcInfo coverages, and once in a while I might have to join to Oracle and bring it together. And when I started working with the city, it was a real shock, because all our data was in a whole bunch of different formats and different locations, different technologies. I mean, we run things like MapInfo, AutoCAD MapGuide, SQL Server, Oracle. So there was a whole bunch of stuff there. And there was basically baling wire holding it all together and making it work.
Yeah, I work in the same situation. Just a little background, Jason works in the IT department for us, managing our server side, and I'm more of the engineering boots in the mud situation. But when I came to the city in 2004, I saw the same situation where we've got disparate data sets spread out across the whole organization, departments that are just held together by pretty much by Jason and baling wire, as you say. And FME has come along and kind of fed us, and that's the topic we had, is bridging all these data silos using an FME and then FME server.
So this is our obligatory economic development slide. Nanaimo is an awesome place to live. You can see it almost looks Mediterranean there. I didn't doctor that image at all. But it also gives you an idea about the size of our organization. 500 to 700 employees, and that's talking about things like summer employment. Most of them don't use GIS directly in their day-to-day jobs, but almost all of them access the GIS data through our web mapping or various other things. And we've had a long history with GIS. So we started using it in 1988 with a package that was built here in, actually built in Nanaimo. It was called TerraSoft. And it was more for resources, but we ended up using it as a city. The nice thing about living in an organization that's relatively small and agile is that we get to do fairly cool stuff. We don't have to build really strict organizational guidelines and stick to one plan. We can kind of move as our needs move, and we can explore new technologies. So within the city, we've got a fairly... did you want to take this one?
Sure. Yeah. So within the city, the GIS is actually not a centralized GIS, as you would see with most organizations. It's really devolved across, and this is just I guess more a growth pattern that's occurred. Is each department has grown their own GIS, their own there's map info here, and I think I saw MicroStation the other day kicking around on somebody's machine. And so we've got all sorts of data sets that I'll go into in the next slide that really we need to bring together. And each department keeps their data, and they keep it to whatever level they decide they want to keep it. So that's it. But these guys need to actually collaborate all that data and publish it out for both public and internal use.
Yeah, from an IT perspective, we can see the level of GIS use, and engineering is probably our most prolific GIS user. They do everything from doing data maintenance in AutoCAD map through to analysis, and doing some really cool custom asset management software and ArcInfo, and some really high-tech 3D data capture stuff using panoramic photography, and we'll show you that a bit later. But there's other departments like planning that maintains our zoning information, and our fire department also uses GIS for their dispatch, and we kind of have to work together informally without any rigid GIS department structure to make sure that all of that data comes together and is published internally and externally in a consistent way.
So there's a bit of a timeline that we'll follow. I showed up somewhere here with this, and really quickly what we started with 2003 FME really kind of got started use with Jason starting off. It was just ad hoc translations. We moved to centralizing some of the data translations that Jason did, and in my department we had a whole number of desktop translations. And now we've just implemented our FME Server instance, which has really brought us all together and given us a lot of power to do so. So when we showed up, this was this is a physical demonstration of the actual data structure within the engineering department when I started. And
okay, there's a disclaimer at the bottom there. Not a City of Nanaimo server room.
I don't know. Yeah, so this is what it looked like, a physical representation of the data structure within my department. Having used FME for a long time, I recognized it as a tool that could deal with this data structure and help us to start moving all those disparate data streams together. So you can kind of see as we grew up in FME real quick here, we sat at the little desk and we did some ad hoc stuff to figure out. We got a bigger desk with little arms on it, and hey, we can run these things at night, and we can actually start throwing away a lot of the things that people are doing in the morning when they come in and they create data. And then we ended up, we've really developed ourselves. We've taken pretty much all our data streams, and we've got desktop FME kicking off on everyone's desktop all over the place, and doing a good job bringing everything together. But of course, we've got 40 or 50 FMWs running here, there, and everywhere, just as we can use our licensing. So.
Yeah, and from an IT perspective, that was a management nightmare because our service windows were shrinking. We didn't know when things were running. We couldn't do maintenance on the corporate GIS servers, and it was getting hard to deal with. I mean, all of these steps have had really strong business cases behind them. I mean, the number of days a month that we're saving using FME at each of these stages was fairly incredible and supported, but it became harder to manage the longer that we were doing it.
So we've moved to a bigger desk, and we've embedded everything into a server integration. For us as an engineering department, we're not an information technology department. We don't have that infrastructure behind us. But we found that by moving to the FME server, that gives us the infrastructure without us having to really put a huge effort into holding servers and centralizing things. Really brings kind of from an operational, if you think of a guy out there in the surveying, he can actually sit at his desktop and upload and manage this situation and see when his translation, when his data is going to run, which has been really nice for us.
So I'm just going to go away from the business case side and talk a little bit of tech now about the experience that we had when we were implementing FME Server in the IT department. We found that there were some best practices that we had to follow. For one thing, we had to run the FME service under a domain account so that it could access all the network shares that were set up. We had to set up a special domain user with privileges to our Active Directory service so that it could read the user accounts using LDAP and we could control logins to the FME server service that way. And we also controlled, in doing that, passing our network passwords around over HTTP, we had to run it under SSL just to make sure that it stayed secure. We also had to do things like set up SQL Server to store the FME repository data in, and we made sure that we stored the FME workspaces, like the share for the workspaces, on a network drive that was snapshotted on a regular basis and could be synchronized with the SQL Server restores. We ran into a minor problem. Somebody decided in all their wisdom to name a network share E_PW, and FME doesn't really like that. Actually, the server job submitter doesn't like that. So we ran into that, and we had to work around it by creating an alias for that share. But apart from that, everything went fairly smoothly. We also found there was a lot of value in storing the FME repository in SQL Server, because it allowed us to apply our corporate SQL reporting tools to the FME translation flow. And I'm going to give you a quick demo of what that looks like. So normally when we log into our FME server, yay! Can't spell my name when I'm in front of our audience. Nice long password. Did you get that? So that was all over SSL, and it's hitting our Active Directory directly. And when you're running FME Server, the admin actually gives you a really cool interface so that you can go in and see what's happened on a daily basis. Unfortunately, I'm pretty lazy, and I don't like logging in every morning and looking at this list. So what we did instead was we created a fairly simple stored procedure that we can access through SQL Server. It's just looking at the FME repository data structure. Let me get back to that last one. And then we rolled that up into an FME Server report under SQL Reporting Server. And that allows you for any day to look at the status of the jobs that were run the previous night. And you can also set up subscriptions, so it's just emailed to you in the morning. So all you have to do is look at your inbox, and you can see which jobs succeeded and which failed. I think we've had about 3 weeks of consistent success. Let me see if I can find one that failed. Maybe not 3 weeks. It feels like 3 weeks. And that comes up, and the failures are expanded. And I'm going to be adding more to this, so I can just click on a hyperlink and open up the log and figure out what happened directly from my email instead of having to log into the server. So those were some of the things that we looked at technically during the implementation. As far as conventions went, when we did the implementation, we found that we had to, within each of the repositories, we had to come up with a consistent naming convention. Tim's is different than mine. So we allocated a repository for engineering and a repository for IT, and within that we just make sure that we all use the same convention so we can tell at a glance which jobs do what things. We also adopted the convention that anything that you upload to FME Server can't write to test. It has to, or can't write to live locations, it has to write to test locations. And then when we schedule that using SQL job submitters, that's where we apply the live transforms. So that we can do as much testing and development as we want directly on FME Server, but once it's scheduled, it runs on live. We've also found that during development, as you're creating new versions of a workspace, you don't want your live scheduled job coming in and running that as you're developing it. So using explicit versions in the file names like v1 or whatever really makes it easy to do incremental development and then move along as you're working.
So we thought we'd do some real quick real-world projects that we actually do in engineering using this technology and show you how it kind of has streamed through. IT had this little camera here that they were using for what was it, tourism?
We wanted to do street view, but our privacy commissioner didn't think it was a good idea.
So we don't have a privacy commissioner in my department apparently. So which I don't know about her. So we stuck this thing on a car because we had operational needs. We wanted to go collect the signage in the city, the actual poles and the signs on top of them, and found out probably a good idea if we're going to manage the stuff. We should know where it is, what it looks like, an asset management process. So we investigated all sorts of different ways that we could actually do that, run out and GPS all the signs, take pictures of the signs, and we came up, we snagged this camera off them, came up with this. And we used FME actually to, can I go to the next one? Oh, there we go. We used FME to actually take that incoming data, and do use FME to take that incoming data from the camera, the GPS, the images, and our road center lines, and meld the whole pile together using transformations as that occurs, and then produce tiles of imagery to come out. This has become an asset management system that FME, the server, sits in the middle of and kind of manages what group looks at as things happen. As operations does work, they get a specific view developed by FME and put in specific. As I say, we have software from map info to Esri to AutoCAD. So we create a whole bunch of different views. And here's just an example. So we drove the whole city and we used FME to actually generate these tiles, these KMLs, that people can go in internally in our organization, click on the road, and take a peek at what's there from any.
Contrast isn't all that great, but it's similar to Google Street View, but we use it internally for capturing things like utility pole locations, street signs, and you can see our Pacific Biological Station. It's a little blurry this far back. Once you get up closer, you can read the signs. So there were some real operational benefits to doing this. I mean, I think you saved probably 60% of the anticipated time by doing it this way.
Yeah, you doing this way and then being able to process so much data quickly and do it. The repeatability of having FME and the FME server. I can now just put this together and dump all three of those data streams: the GPS, the imagery, the road center line, and have it come out again and refresh my imagery automatically. Another thing that we do, of course, is data distribution within for engineering data, both to the public and our consultants. FME, which one is it here? There it is. So FME, the server allows us just to set up all those different data formats and create a site. Or we can actually provide that out without having to do any work, or they can just go to this site and get their data. Yeah,
there you go. So this is the canonical RESTful GIS photo, is made popular on James Fee's blog, and that's from iStock Photo, so anybody can get that picture and use it in their presentations. I'm not going to talk about REST so much as the value of the service that FME is allowing us to provide to our residents. Our RESTful interface is run through MapGuide, but on the back end, all of the data that goes in there is processed through FME Server so that we can offer a current version of the data to residents on a nightly basis. And the cool thing about this interface is that as James was talking about this morning, is it's all about findability and usability. It's not so much about people going to a website and downloading GIS data and doing analysis. It's about us serving the public in a way that they get easy access to the city's data without having to go through some kind of convoluted interface. They can just search Google for the data. So I've got a basic search interface for it. So if you search for any particular address, it gives you a list of them. But the nice thing about this is you can search in Google for any of these addresses and also access our data that way. So if somebody's looking for a particular address, they can go right to the site map from there without even having to go anywhere else on our website and figure out our different interface for it. So that's providing a huge amount of value to our residents because they don't have to learn special interfaces for just to access our data. And we're hoping to do this with more than just our spatial data. We're hoping to do it with other kinds of non-spatial data and just making sure that it's optimized for the search engines to find individual records instead of having to find data sets. So start the show again. So there's some of the results. From an IT perspective, the main thing for us is reduced time. It gives us a larger service window and it increases the reliability for us. It means that we can offer backup services to departments like Tim's so that if something happens to their workspace, they can go back to the last hourly snapshot or the last daily snapshot and we can restore that and they can be back up and running again. We don't have to worry about power failure on one of the non-UPS's UPS desktops blowing up, I don't know, 20 users' operational view of the data. So bringing that into a central location where we can provide those services, but we don't have to act as a bottleneck for the department. We don't have to stand there and say, okay, we'll bring this into our system and we'll do some QA on it. We can let them manage all of their transforms within FME Server just by saying, here, this is a repository, here's a driver workspace that will run once a night for you or whatever schedule you decide and you manage it from there. So it's really taken a lot of the responsibility away from us and allowed them to innovate a lot faster than they would when they have to go through us. Was there anything additional on that was important to you?
I think those are all self-explanatory, those ones, yeah. So what do we see from an operational standpoint? A lot of on-demand work for people analyzing data internally. And as an engineer, you want to look at something and you want to have control over how you look at that data. So FME Server, of course, we can publish our parameters and we can let them configure the answer that they're looking for out of a base operational data set. So those are configurable spatial. We can give you an area. The real big bonus for us as engineering is we have some way to manage all these FMWs that are going on. You guys, the naming convention and a central place. And we can develop our own specific transformers for our needs and then share them out fairly efficiently too.
So I think the main takeaway here is that we're moving away from the desk and the sky's the limit. So that's the end of our presentation and we'd be happy to take any questions.